Today, we're going to tackle something that sits at the very foundation of, well, everything. We're going to challenge our most basic assumption about the universe, the very existence of space. So let me just start by asking you this. If you had to boil it all down, what's the single most fundamental thing in the universe? You might think of matter, or maybe energy, maybe even time itself. But for most of us, I think the gut answer is space. That huge, empty stage where the whole cosmic drama plays out. It's the box that holds everything else. I mean, Newton thought it was absolute. Einstein showed it could bend and warp. But they both agreed on one core thing. Space is there. But what if that's the greatest illusion of them all? What if, when you get down to the absolute bedrock of reality, there is no space? Now, that single, kinda chilling idea is right at the cutting edge of physics. And that's exactly what we're going to unpack today. All right, so to really wrap our heads around this, first we have to deconstruct our old idea of space as this pre-existing container. It's time to literally tear down the stage of reality. The source material gives us this absolutely beautiful metaphor. Space isn't some passive stage that things happen on. It's the active embrace of the actors, you see? It's a relationship. It's a connection between things, not a void that keeps them apart. And this slide really nails that shift in thinking. On the left, you've got the classical view, the old way of thinking. Space is just an empty box. But on the right, the new view, this radical idea from the frontiers of physics, says no. Space is a dense, interconnected network, a fabric woven from nothing more than pure information and connection itself. This illusion goes so deep that it completely redefines what distance even means. It's not a physical length you can measure with a ruler anymore. In this new model, distance is just a way of talking about how weakly two objects are connected by information. The farther apart they seem to us, the weaker their quantum entanglement. So distance isn't a gap, it's just a weak connection. So if space is an illusion, what's actually real? Okay, let's move on and see how reality is actually built, stitch by stitch from the ground up. The fundamental building block, the cosmic thread that weaves this whole fabric, turns out to be quantum entanglement. We used to call it spooky action at a distance, right? But this new way of looking at it totally reframes that. It's not spooky. It's the very glue that holds space itself together. And the process for weaving reality is actually incredibly elegant. So, step 1. You start with the fundamental pixel of reality, a single bit of quantum information, or a qubit. Step 2, you use the thread of maximum entanglement, what physicists call a Bell pair, to connect two of those pixels. And finally, step 3, you just weave trillions upon trillions of these threads into this vast interconnected fabric that we perceive as space-time. It's a structure called a tensor network. And all those fundamental forces we learned about in school, they're really just different kinds of stitches in the fabric. The strong force, that's like a super tight, dense stitch holding the middle of atoms together. Gravity is more like a long, sparse stitch holding entire galaxies together. It's amazing. Without these stitches, space would literally just fall apart. Okay, but wait a second. This brings up a huge question. If our reality is just woven together from all these delicate little quantum threads, why does it feel so incredibly stable and solid? I mean, really think about it. Quantum states are famously fragile. So why doesn't this cosmic tapestry just unravel? Why isn't reality constantly glitching and breaking down on us? The answer is it's genius. It turns out that space-time isn't just a fabric, it's an incredibly sophisticated piece of code. A quantum error-correcting code, to be exact. See, just like on a really well-designed hard drive, the crucial information isn't stored in just one tiny spot. No, it's spread out, it's redundant across the entire network. And that makes the whole system unbelievably tough. If you snap one tiny thread, it doesn't matter, because the information is still safe. It's backed up everywhere else. And this idea leads to one of the most mind-bending concepts in all of modern physics, the holographic principle. This slide is like a dictionary, translating between our familiar 3D world, what physicists call the bulk, and a 2D informational code that exists on the boundary of the universe. It's like a hologram, right? The 3D image is encoded on a 2D surface. So here, the area of a surface in our world corresponds directly to the amount of entanglement in the code, and the volume of space itself
Turns out that's just a measure of the code's computational complexity. The takeaway here is staggering. Geometry is information.
This new understanding of space as this informational code, well, it has some profound implications. So let's start with the big one, gravity. So get ready for this. This new picture completely overhauls how we think about gravity. It's not a fundamental force that acts inside of space. Instead, gravity is what emerges from the informational network that creates space to begin with. Let's think of it like a computer network. In this view, mass is just a point of extreme information density. It's like a congested server on the cosmic internet. And what we call space-time curvature, or gravity, that's just the network rerouting all the information traffic around that congested point. And time dilation? Well, that's just the processing lag you get near a server that's being totally overwhelmed. Gravity, then, is literally the weight of information itself. Okay, this is where it gets really, really wild. If reality is a woven code, does that mean we can hack it? Can we create our own shortcuts? The key, believe it or not, is this deceptively simple equation, ER equals EPR. It was proposed back in 2013, and it brilliantly connects two of Einstein's biggest ideas from way back in 1935. For what on earth does it mean? Well, ER stands for an Einstein-Rosen bridge, yep, a wormhole. And EPR stands for an Einstein-Podolsky-Rosen pair, which is just our old friend quantum entanglement. The equation says they're the same thing. They're just two different ways of describing the exact same physical reality. A wormhole is just what entanglement looks like from the outside. And this gives us a theoretical blueprint for hacking space-time. Step 1, you create a massive amount of entanglement between two very distant locations. Step 2, you compress the matter at both ends until they collapse into black holes. And then, voila, a wormhole, a real geometric tunnel, now connects those 2 points right through space-time. The implication here is just staggering. It means that mastering interstellar travel might not be about building faster and faster ships. It might actually be about mastering the art of sewing, of stitching 2 points in the cosmic fabric together with threads of entanglement. And all of this, all of it, leaves us with one final profound question. If space isn't fundamental, if our entire reality is just an emergent program running on some kind of cosmic computer, then who or what wrote the code?